Did you know that AI engineering jobs are projected to grow by 26% in the next decade? That's over 5 times faster than the average job growth rate. If you're considering a career in AI, now is the time to act. But where do you start? This video lays out a clear week-by-week plan using only free resources to launch your AI career. The world of artificial intelligence is buzzing with excitement and opportunity. Every day we hear about groundbreaking AI applications, from self-driving cars to advanced medical diagnostics. It's a field that's growing at an unprecedented rate, promising innovation and transformation across industries. This rapid advancement is creating a surge in demand for skilled AI professionals. But alongside this enthusiasm, there's a palpable sense of anxiety and confusion. Many aspiring AI engineers find themselves overwhelmed by the sheer volume of information available. They're bombarded with countless online courses, bootcamps, and certifications, each claiming to be the key to a successful AI career. The landscape is cluttered with expensive training programs and conflicting advice, leaving many feeling lost and unsure of where to start. This information overload is particularly challenging for those trying to break into the field. Aspiring AI engineers often find themselves asking, what skills do I really need? Which programming languages should I focus on? How much math is actually required? The answers to these questions are not always clear-cut, and the confusion can be paralyzing. Adding to this complexity is the rapid pace of change in AI technology. What's cutting edge today might be outdated tomorrow, making it difficult for learners to know if they're investing their time and resources wisely. This constant evolution can make traditional learning paths seem insufficient or outdated. Despite these challenges, the potential rewards of an AI career are substantial. The job market for AI professionals is experiencing explosive growth. According to a report by LinkedIn, artificial intelligence specialist was the top emerging job in 2020, with 74% annual growth in hiring over the previous 4 years. The U.S. Bureau of Labor Statistics projects a 22% growth rate for computer and information research scientists, which includes AI specialists, from 2020 to 2030, much faster than the average for all occupations. The salary potential in AI engineering is equally impressive. Glassdoor reports that the average base salary for AI engineers in the United States is around $140,121 per year, with experienced professionals often earning much more. Some top AI researchers and engineers at leading tech companies command salaries in the high 6 or even 7 figures. However, these promising statistics can also contribute to misconceptions about AI engineering careers. One common myth is that you need a PhD to work in AI. While advanced degrees can certainly open doors, many successful AI engineers have bachelor's degrees or even alternative educational backgrounds. Another misconception is that AI is all about coding. In reality, AI engineering requires a blend of skills, including data analysis, problem solving, and domain expertise. There is also a prevailing belief that AI is a monolithic field, when in fact, it encompasses a wide range of specializations, from natural language processing to computer vision to robotics. This diversity of subfields can be both exciting and daunting for newcomers. Traditional learning paths, while valuable, may not always keep pace with the rapidly evolving AI landscape. University curricula can take years to update, and by the time a student graduates, the tools and techniques they learned might already be outdated. Even many online courses and bootcamps struggle to stay current, often teaching concepts that are already several years old. Moreover, these traditional paths often focus heavily on theory at the expense of practical hands-on experience. While theoretical knowledge is crucial, employers in the AI field increasingly value candidates who can demonstrate real-world problem-solving skills and familiarity with current tools and frameworks. So, what's the solution to this challenge? How can aspiring AI engineers navigate this complex landscape and build the skills they need to succeed? The answer lies in a structured, comprehensive learning roadmap that leverages free, up-to-date resources. Imagine having a clear, week-by-week plan that guides you through every aspect of AI engineering, from foundational computer science concepts to advanced machine learning techniques. A roadmap that not only teaches you the technical skills, but also helps you develop the problem-solving abilities and industry insights that employers value. And best of all, one that utilizes freely available resources, eliminating the need for expensive bootcamps or degree programs. This kind of structured approach can transform the overwhelming world of AI learning into a manageable, step-by-step journey. It can provide clarity amidst the confusion, helping learners focus on what truly matters and avoid wasting time on irrelevant or outdated information. But before we dive into this roadmap, it's crucial to understand the core skills that form the foundation of AI engineering. These skills go beyond just programming or mathematics. They encompass a range of technical and soft skills that are essential for success in this field. While many aspiring AI engineers focus solely on mastering the latest tools, true success in this field hinges on a set of fundamental skills that are often overlooked. What are these critical building blocks that form the foundation of AI engineering? The answer might surprise you. At its core, AI engineering is built upon a strong foundation in computer science and mathematics. These disciplines provide the essential framework for understanding and developing complex AI systems. However, it's crucial to dispel a common misconception. AI is not just about coding or using pre-built tools. In fact, the most successful AI engineers possess a diverse set of skills that go far beyond simply writing code. Let's start with computer science fundamentals. These principles are the bedrock upon which all AI development is built. Understanding data structures, algorithms, and computational complexity is essential for designing efficient and scalable AI solutions. For instance, knowing how to implement and optimize search algorithms can significantly improve the performance of an AI system tasked with finding optimal solutions in large problem spaces. But computer science alone isn't enough. Mathematics plays an equally critical role in AI engineering. Three key areas of mathematics are particularly important: linear algebra, calculus, and probability theory. Linear algebra provides the tools for working with high-dimensional data and understanding the geometric relationships between data points. Calculus is crucial for optimization problems, which are at the heart of many machine learning algorithms. Probability theory helps in modeling uncertainty and making informed decisions based on incomplete information. Consider, for example, the task of developing a recommendation system for an e-commerce platform. An AI engineer would need to use linear algebra to represent user preferences and item features as vectors, calculus to optimize the recommendation algorithm, and probability theory to model the likelihood of a user enjoying a particular item. Problem solving and algorithmic thinking are two more critical skills that set successful AI engineers apart. These abilities allow engineers to break down complex problems into manageable components and devise efficient solutions. It's not just about finding any solution, it's about finding the best solution given the constraints of the problem. This skill is particularly valuable when dealing with novel AI challenges that don't have pre-existing solutions. Now, let's talk about programming languages. While it's true that AI engineering involves coding, it's the choice of language and how it's used that matters most. Python has emerged as the go-to language for AI development due to its simplicity, extensive libraries, and strong community support. R is another popular choice, particularly for statistical analysis and data visualization. Java, with its robustness and scalability, is often used for building large-scale AI systems. However, it's important to note that proficiency in these languages goes beyond just syntax. A skilled AI engineer understands how to leverage the unique features of each language to implement AI algorithms efficiently. For instance, using Python's NumPy library for fast numerical computations, or R's ggplot2 for creating insightful visualizations of AI model outputs. These foundation skills are non-negotiable for aspiring AI engineers. They form the bedrock upon which all advanced AI concepts are built. Without a solid grasp of these fundamentals, it becomes incredibly challenging to understand, implement, and innovate in the field of AI. Consider the development of a natural language processing model. Without a strong foundation in computer science, an engineer might struggle to implement efficient text processing algorithms. Without a solid understanding of linear algebra and calculus, they would find it difficult to grasp the mathematics behind word embeddings and gradient descent optimization. And without proficiency in Python and its machine learning libraries, they would struggle to implement and train the model effectively. This is why these foundation skills are so crucial. They enable AI engineers to understand complex AI concepts at a deep level rather than just superficially using pre-built tools. They provide the flexibility to adapt to new AI technologies and techniques as they emerge. And perhaps most importantly, they empower engineers to innovate and push the boundaries of what's possible in AI. Now that we've covered the essential building blocks, you might be wondering, is it really possible to become a job-ready AI engineer in just 8 months? The answer lies in a carefully structured learning plan that challenges conventional timelines. While it may seem daunting to compress years of learning into such a short period, this roadmap is designed to maximize efficiency and focus on the most crucial skills and knowledge needed to enter the field. The 8-month plan is built on the principle of progressive skill development, where each month builds upon the foundation laid in the previous one. This approach ensures that learners don't just accumulate isolated bits of knowledge, but develop a cohesive understanding of AI engineering as a whole. The roadmap begins with a strong focus on reinforcing fundamental computer science and mathematics concepts. This isn't just a rehash of basic principles, but a targeted approach to apply these concepts directly to AI problems. For instance, learners will explore how graph theory can be used to model complex relationships in social networks, or how linear algebra is applied in dimensionality reduction techniques for machine learning. As the journey progresses, the plan introduces more specialized AI topics. This includes diving into machine learning algorithms, exploring neural network architectures, and understanding the intricacies of deep learning. The key here is not just to learn the theoretical aspects, but to immediately apply this knowledge through hands-on projects and real-world data sets. One of the unique aspects of this roadmap is its emphasis on practical application alongside theoretical learning. Each month includes specific project goals that align with the topics being studied. For example, while learning about natural language processing, participants might build a sentiment analysis tool for social media posts. This approach ensures that learners don't just understand concepts in isolation, but can apply them to solve actual problems. The plan also incorporates a gradual introduction to industry standard tools and frameworks. Instead of overwhelming learners with every available tool, it focuses on mastering a core set of technologies that are widely used in the AI industry. This includes gaining proficiency in TensorFlow or PyTorch for deep learning, understanding how to use cloud platforms for large-scale AI computations, and learning best practices for version control and collaborative coding. A critical component of the roadmap is its focus on developing soft skills alongside technical expertise. This includes learning how to effectively communicate complex AI concepts, understanding the ethical implications of AI technologies, and developing problem-solving strategies specific to AI challenges. These skills are often overlooked in traditional curricula, but are crucial for success in real-world AI roles. The plan also addresses the rapidly evolving nature of AI by incorporating modules on staying up to date with the latest research and developments. This includes learning how to read and understand academic papers, participating in AI competitions on platforms like Kaggle, and contributing to open source AI projects. While the roadmap offers a structured path, it's designed to be flexible enough to accommodate different learning styles and backgrounds. It provides options for deeper exploration in areas of particular interest or relevance to an individual's career goals. This flexibility ensures that learners can tailor their journey to align with their specific aspirations within the broad field of AI. One of the most significant challenges in such an intensive learning journey is maintaining consistency and motivation. The roadmap addresses this by incorporating regular milestones and checkpoints. These serve not only as progress markers, but also as opportunities for reflection and course correction if needed. The plan also suggests forming study groups or finding mentors to provide support and accountability throughout the journey. It's important to acknowledge that this accelerated path to AI expertise is not without its challenges. The learning curve can be steep, and the time commitment required is substantial. Learners may face periods of frustration or self-doubt, especially when tackling complex topics or debugging challenging projects. However, the roadmap includes strategies for overcoming these hurdles, such as breaking down complex problems into manageable parts and seeking help from online communities when stuck. The mini payoff of this roadmap is its potential to transform a beginner into a job-ready AI engineer in a relatively short time frame. By the end of the 8 months, learners will have not only gained a comprehensive understanding of AI principles, but also built a portfolio of projects demonstrating their skills. This practical experience, combined with the ability to discuss AI concepts in depth, positions graduates of this program to be competitive candidates for entry-level AI engineering roles. As we begin our AI engineering journey, you might wonder why we're not jumping straight into TensorFlow or PyTorch. The answer lies in a fundamental principle of engineering that's often overlooked in the rush to learn cutting-edge technologies. This principle is the importance of a solid foundation, and in the world of AI, that foundation is built on computer science basics. Think of computer science as the language of machines. Just as learning a new spoken language opens up a world of communication, mastering computer science fundamentals unlocks the ability to communicate effectively with computers and, by extension, develop sophisticated AI systems. But why is this so crucial for AI engineering? AI systems, at their core, are complex algorithms running on powerful hardware. Without a deep understanding of how these algorithms work, how data is structured and manipulated, and how computers process information, you'll be limited in your ability to innovate and solve problems in AI development. It's like trying to write a novel without first learning grammar and vocabulary. You might be able to string some words together, but creating a coherent, impactful story would be nearly impossible. Let's break down some of the key computer science concepts that we'll be covering in the first 2 weeks of our journey. We'll start with algorithms, the step-by-step procedures for solving problems or performing tasks. In AI, algorithms are the backbone of everything from simple decision trees to complex neural networks. Understanding how to design efficient algorithms will be crucial when you're optimizing AI models for speed and accuracy. Next, we'll dive into data structures, the various ways of organizing and storing data for efficient access and modification. In AI, you'll be working with massive data sets, and knowing how to structure this data can make the difference between a model that runs in seconds and one that takes hours. We'll explore structures like arrays, linked lists, trees, and graphs, each with its own strengths and use cases in AI applications. We'll also cover networking basics. While this might seem tangential to AI, many AI systems operate in distributed environments or rely on cloud computing. Understanding how data moves between computers and across the internet will be invaluable when you're designing AI systems that need to process data from multiple sources or deploy models across different machines. Now, I know some of you might be feeling impatient. You signed up to learn about AI, not to revisit Computer Science 101, but trust me, this foundation will accelerate your AI learning in ways you can't yet imagine. When you understand these basics deeply, learning AI-specific concepts becomes much easier and faster. To make the most of these 2 weeks, I recommend dedicating at least 2 to 3 hours each day to studying. This might seem like a lot, but remember, we're condensing what could be a semester-long course into just 2 weeks. The good news is that there are plenty of free resources available to help you learn these topics. For algorithms and data structures, I highly recommend the Algorithms course on Coursera by Princeton University. It's free to audit and provides an excellent introduction to these fundamental concepts. For networking basics, the Computer Networking course by Georgia Tech on Udacity is a great resource. Both of these courses include practical programming exercises that will help reinforce your learning. Speaking of programming, while we won't be diving deep into any specific language yet, it's a good idea to start familiarizing yourself with Python syntax. Python will be our primary language for AI development, and getting comfortable with its basics now will save you time later. The official Python tutorial is a great place to start. As you're studying, try to relate each concept back to AI. For example, when learning about graph data structures, think about how they might be used to represent neural networks. When studying sorting algorithms, consider how they might be applied to organize training data for machine learning models. This practice of connecting concepts to real-world applications will not only make your learning more engaging, but also help you retain information better. To make the most of your study time, I recommend using active recall techniques. After each study session, try to explain the concepts you've learned without referring to your notes. This might feel difficult at first, but it's one of the most effective ways to ensure you're truly understanding and retaining the information. Also, don't hesitate to seek help when you're stuck. There are numerous online communities such as Stack Overflow and Reddit's r/arch Learn Programming, where you can ask questions and get support from experienced programmers. Remember, every expert was once a beginner, and most are happy to help others on their learning journey. Now that we've laid the groundwork, it's time to focus on the Swiss Army knife of AI development. But why has Python become the backbone of artificial intelligence, and how can you harness its power in just 2 weeks? Let's explore the world of Python and its crucial role in AI engineering. Python has emerged as the go-to language for AI development due to its simplicity, versatility, and powerful ecosystem of libraries and frameworks. Its clean and readable syntax makes it an ideal choice for both beginners and experienced programmers alike. This accessibility allows AI engineers to focus on solving complex problems rather than getting bogged down in intricate code structures. One of Python's greatest strengths is its extensive collection of libraries, specifically designed for AI and machine learning tasks. These libraries provide pre-built functions and tools that simplify the process of developing AI applications. For instance, NumPy offers efficient array operations and mathematical functions, while Pandas excels at data manipulation and analysis. Matplotlib, on the other hand, enables the creation of stunning visualizations to help interpret complex datasets and model outputs. Learning a new programming language might seem daunting, especially if you're new to coding or coming from a different language background. However, Python's gentle learning curve and intuitive design make it an excellent choice for aspiring AI engineers. The language's emphasis on readability and simplicity aligns well with its philosophy of there should be one, and preferably only one, obvious way to do it, which helps reduce confusion and promotes consistent coding practices. To master Python in 2 weeks, it's essential to follow a structured learning plan. Start by familiarizing yourself with Python's basic syntax, data types, and control structures. Once you've grasped these fundamentals, move on to more advanced concepts such as functions, object-oriented programming, and file handling. Dedicate time each day to practice coding exercises and small projects to reinforce your learning. Several free resources are available to help you on your Python learning journey. Websites like Codecademy and Free Code Camp offer interactive Python courses that cover both basics and advanced topics. For a more comprehensive understanding, consider enrolling in the Introduction to Computer Science and Programming Using Python course offered by MIT through edX. This course provides a solid foundation in computer science principles while teaching Python. To enhance your practical skills, make use of coding practice platforms like HackerRank or LeetCode. These sites offer a wide range of programming challenges that will help you apply your Python knowledge to solve real-world problems. Additionally, participating in coding competitions on these platforms can be an excellent way to benchmark your progress and identify areas for improvement. As you embark on your Python learning journey, be aware of common pitfalls that many beginners face. One such pitfall is the temptation to memorize syntax without understanding the underlying concepts. Instead, focus on grasping the logic behind Python's constructs and how they can be applied to solve problems. Another common mistake is trying to learn everything at once. Remember that mastering a programming language is a gradual process, so pace yourself and celebrate small victories along the way. Another challenge you might encounter is the vast number of libraries and frameworks available in the Python ecosystem. While it's exciting to explore these tools, it's crucial to avoid getting overwhelmed. Start with the core libraries essential for AI development, such as NumPy, Pandas, and Matplotlib. As you progress, you can gradually expand your knowledge to include more specialized libraries like scikit-learn for machine learning or TensorFlow for deep learning. Don't underestimate the power of building small projects as you learn. Creating simple applications or scripts that solve real problems will help solidify your understanding of Python and its applications in AI. For example, you could build a basic recommendation system using collaborative filtering techniques or implement a simple neural network from scratch. These projects will not only reinforce your learning, but also serve as valuable additions to your portfolio. As you become more proficient in Python, you'll start to appreciate its seamless integration with popular AI frameworks and tools. Libraries like TensorFlow and PyTorch, which are essential for deep learning, have robust Python interfaces that allow you to build and train sophisticated neural networks with relative ease. Similarly, natural language processing tasks become more manageable with libraries like NLTK and SpaceI, which offer powerful text processing capabilities through intuitive Python APIs. Python's versatility extends beyond traditional AI applications. Its data analysis capabilities make it an excellent choice for tasks like exploratory data analysis and feature engineering, which are crucial steps in any AI project. The language's ability to handle large data sets efficiently, coupled with its rich ecosystem of data visualization tools, enables AI engineers to gain valuable insights from complex data structures. Picture this. You've built an impressive AI model, but when you run it on a large data set, it crawls at a snail's pace. What went wrong? The answer likely lies in the often overlooked foundations of computer science, data structures, and algorithms. These aren't just academic concepts. They're the building blocks that can make or break your AI systems. As we shift our focus from Python to the core of computer science, we'll uncover the toolkit that separates groundbreaking AI models from sluggish prototypes. Over the next 2 weeks, we'll explore how the right data structure can transform a slow, memory-hungry algorithm into a lightning-fast, efficient solution. Let's start with data structures, the organizational systems that dictate how we store and access information. Arrays, for instance, are the workhorses of many AI applications. They allow for quick, random access to elements, making them ideal for tasks like storing feature vectors in machine learning models. However, their fixed size can be a limitation when dealing with dynamic data. Linked lists offer more flexibility. Unlike arrays, they can grow or shrink as needed. making them useful for implementing adaptive AI algorithms that adjust their parameters on the fly. But this flexibility comes at a cost. Accessing elements in a linked list is generally slower than in an array. Trees and graphs take us into more complex territory, but they're essential for many AI applications. Decision trees, a fundamental concept in machine learning, use a tree-like structure to make predictions. Graphs, on the other hand, are crucial for representing complex relationships, such as social networks or recommendation systems. Now, let's talk algorithms. The step-by-step procedures that process our data. Sorting algorithms like quicksort or merge sort are fundamental for organizing data efficiently. In AI, sorted data can significantly speed up search and retrieval operations, crucial for tasks like nearest neighbor calculations in clustering algorithms. Searching algorithms are equally important. Binary search, for example, can dramatically reduce the time needed to find specific data points in large datasets. This efficiency is crucial when working with massive training sets or when an AI system needs to make real-time decisions. Graph traversal algorithms such as depth-first search and breadth-first search are the backbone of many AI applications. They're used in everything from pathfinding in robotics to analyzing social networks for targeted advertising. But how do these concepts translate to real-world AI applications? Consider a recommendation system for an e-commerce platform. The system might use a graph structure to represent relationships between products, with edges indicating when products are frequently bought together. A depth-first search algorithm could then traverse this graph to find related products, while efficient sorting algorithms ensure that the most relevant recommendations appear first. Or think about natural language processing. Efficient string matching algorithms are crucial for tasks like spell checking or autocomplete. Try data structures, a type of tree optimized for string operations, can significantly speed up these processes. To master these concepts, you'll need a structured learning plan. Start by focusing on one data structure or algorithm at a time. Implement them from scratch in Python to truly understand their inner workings. Then, analyze their time and space complexity to appreciate when and why certain structures or algorithms are more efficient than others. Practice is key. Coding platforms like LeetCode and HackerRank offer a wealth of problems that will challenge your understanding and improve your problem-solving skills. Start with easier problems and gradually work your way up to more complex ones. For free resources, MIT's Introduction to Algorithms course is available on OpenCourseWare. It provides comprehensive coverage of data structures and algorithms, complete with lecture notes and problem sets. Another excellent resource is the Algorithms Specialization on Coursera, offered by Stanford University. While the certificate isn't free, you can audit the courses at no cost. As you work through these resources, remember to relate what you're learning back to AI applications. How might a particular data structure be used in a neural network? How could a specific algorithm optimize the training process of a machine learning model? By the end of these 2 weeks, you'll have gained a powerful set of tools that will set you apart as an AI engineer. You'll understand not just how to implement AI algorithms, but how to optimize them for peak performance. This knowledge will allow you to build AI systems that can handle massive data sets with ease, process information at lightning speed, and make efficient use of computational resources. You've mastered the art of optimizing algorithms, but what good is speed without substance? Data science is where the rubber meets the road in AI. It's the key to transforming raw information into game-changing insights. As we enter weeks 7 and 8 of our AI engineering journey, we'll explore why data science is crucial for AI and how deep we need to go to make a real impact. Data science and AI are deeply intertwined. While AI provides the tools to process and learn from data, data science provides the framework for understanding, preparing, and interpreting that data. Without solid data science skills, even the most advanced AI algorithms can fall flat. The scope of data science can be overwhelming. It encompasses a wide range of topics, from statistical analysis to data visualization. But don't worry, we're not aiming to turn you into a full-fledged data scientist in just 2 weeks. Instead, we'll focus on the core concepts that are most relevant to AI engineering. Let's start with some key statistical concepts. Probability is the foundation of many AI algorithms, especially in machine learning. Understanding probability distributions is crucial for modeling uncertainty and making predictions. For example, when working with natural language processing, you'll often encounter the Poisson distribution to model word frequencies in text. Hypothesis testing is another important concept. It allows us to make inferences about populations based on sample data. This is particularly useful in A/B testing scenarios where you might be comparing the performance of different AI models. Data pre-processing is a critical step in any AI project. Raw data is often messy, inconsistent, and full of noise. Cleaning this data involves handling missing values, removing duplicates, and correcting errors. Normalization is another important pre-processing technique which scales numerical features to a standard range. This is crucial for many machine learning algorithms that are sensitive to the scale of input features. Feature engineering is where domain knowledge meets data science. It involves creating new features from existing data to improve model performance. For instance, in a time series prediction task, you might create lag features or rolling averages to capture temporal patterns. Data visualization is a powerful tool in the AI engineer's arsenal. It allows you to uncover patterns, identify outliers, and communicate results effectively. Tools like matplotlib and Seaborn in Python make it easy to create insightful visualizations. For example, you might use a heat map to visualize the correlation between different features in your dataset, helping you identify redundant information. Exploratory data analysis, EDA, is the process of analyzing and summarizing datasets to gain insights. It's often the first step in any AI project, helping to guide feature selection and model choice. Through EDA, you might discover that certain features have a non-linear relationship with your target variable, suggesting the need for a more complex model. Now, let's outline a structured plan for learning these data science fundamentals. Days 1 to 3, focus on probability and statistics. Start with basic probability concepts, then move on to common distributions and hypothesis testing. Use resources like Khan Academy for clear explanations and practice problems. Days 4 to 6, dive into data pre-processing. Learn about different types of data, numerical, categorical, ordinal, and how to handle each. Practice cleaning messy data sets and applying normalization techniques. The scikit-learn library in Python provides excellent tools for this. Days 7 to 9, explore data visualization. Start with basic plots like histograms and scatter plots, then move on to more advanced visualizations like heat maps and pair plots. Work through the matplotlib and Seaborn tutorials to get hands-on experience. Days 10 to 12, study feature engineering techniques. Learn about common methods like one-hot encoding for categorical variables and creating interaction features. Apply these techniques to real datasets to see their impact. Days 13 to 14, practice exploratory data analysis. Combine all the skills you've learned to analyze datasets from start to finish. The UCI Machine Learning Repository provides a wealth of datasets to practice on. Throughout this 2-week period, aim to spend at least 2 to 3 hours each day on these topics. Remember to apply active recall techniques such as summarizing what you've learned or explaining concepts to an imaginary student to reinforce your understanding. By the end of these 2 weeks, you'll have gained a solid foundation in data science that will significantly enhance your AI engineering skills. You'll be able to approach data sets with confidence, extract meaningful insights, and prepare data effectively for AI algorithms. You've laid the groundwork with data science, but now it's time to breathe life into your AI systems. Over the next 4 weeks, we'll unravel the mystery of how machines can actually learn from data. It's a concept that might seem paradoxical at first. How can a computer learn without being explicitly programmed? The answer lies in machine learning, and we're about to discover how seemingly simple algorithms can lead to remarkably intelligent behavior. Machine learning is the backbone of modern AI systems, enabling computers to improve their performance on a specific task through experience. It's a vast field with numerous approaches, but we'll focus on the core principles and most widely used techniques to give you a solid foundation. We'll start by diving into the two main categories of machine learning: supervised and unsupervised learning. In supervised learning, we train our models on labeled data, teaching them to make predictions or decisions based on past examples. This is like having a teacher who provides the correct answers during training. Unsupervised learning, on the other hand, deals with unlabeled data, where the model tries to find patterns or structure on its own. One of the first algorithms we'll explore is linear regression, a fundamental technique used for predicting numerical values. It's a great starting point because it's relatively simple to understand and implement, yet it forms the basis for more complex models. We'll see how this algorithm can be used to predict house prices based on features like square footage, number of bedrooms, and location. Next, we'll move on to decision trees, a powerful and intuitive algorithm that makes decisions based on a series of questions. Decision trees are particularly useful because they're easy to interpret and can handle both numerical and categorical data. We'll learn how to construct these trees and use them for classification tasks, such as predicting whether a customer will churn or not. Clustering algorithms will introduce us to the world of unsupervised learning. We'll explore how these techniques can group similar data points together without any predefined labels. This has numerous real-world applications, from customer segmentation in marketing to anomaly detection in cybersecurity. Throughout our journey into machine learning, we'll emphasize the critical role of feature selection and engineering. The performance of our models heavily depends on the quality and relevance of the features we use. We learn techniques to select the most informative features and create new ones that capture important aspects of our data. To make this learning journey more structured and manageable, we've broken it down into a week-by-week plan. Week 1, Foundations and Supervised Learning. Days 1 to 2, Introduction to Machine Learning Concepts and Terminology. Days 3 to 4, Linear Regression and its Applications. Days 5-7, Classification Algorithms, focusing on decision trees. Week 2, Unsupervised Learning and Model Evaluation. Days 1 to 3, Clustering Algorithms and their Applications. Days 4 to 5, Dimensionality Reduction Techniques. Days 6 to 7, Model Evaluation Metrics and Cross-Validation. Week 3, Feature Engineering and Selection. Days 1 to 3, Techniques for Creating New Features. Days 4 to 5, Methods for Selecting the Most Relevant Features. Days 6 to 7, Handling Imbalanced Datasets and Dealing with Outliers. Week 4, Practical Implementation and Advanced Topics. Days 1 to 3, Implementing Machine Learning Models using Scikit-learn. Days 4 to 5, Introduction to Ensemble Methods, Random Forests, Gradient Boosting. Days 6-7, Real-World Case Studies and Ethical Considerations in ML. To support your learning, we recommend several free resources. Coursera offers an excellent machine learning course by Andrew Ng, which provides a comprehensive introduction to the field. For a more hands-on approach, FastAI's Practical Deep Learning for Coders course is an excellent choice, even though it goes beyond traditional machine learning. As you progress through these topics, it's crucial to apply your knowledge through practical projects. Start with simple tasks like predicting housing prices or classifying images of handwritten digits, then gradually move on to more complex projects such as building a recommendation system or a sentiment analysis tool for social media posts. Remember, the learning curve can be steep at times. Machine learning algorithms often involve complex mathematics and statistical concepts. Don't get discouraged. If you don't grasp everything immediately, focus on understanding the intuition behind each algorithm first, then gradually dive into the mathematical details. One effective strategy is to visualize the algorithms in action. Many online tools and libraries allow you to interactively explore how different algorithms work. For example, you can use tools like TensorFlow Playground to visualize neural networks, or scikit-learn's interactive decision tree visualization to understand how these models make decisions. You've seen how machines can learn from data, but can they truly mimic human cognition? The next frontier of AI lies in deep learning, a realm where artificial neurons fire in ways that might make you question the limits of machine intelligence. As we embark on weeks 13 to 16 of our AI engineering journey, we'll unravel the mysteries of neural networks and explore how they're revolutionizing the field of artificial intelligence. At its core, deep learning is inspired by the structure and function of the human brain. Just as our brains consist of interconnected neurons that process and transmit information, artificial neural networks are composed of layers of nodes that work together to recognize patterns and make decisions. These networks can have hundreds or even thousands of layers, each responsible for detecting different features or abstractions within the data. The complexity of deep learning architectures can be daunting at first. Unlike traditional machine learning models, which often rely on hand-engineered features, deep learning networks can automatically learn to extract relevant features from raw data. This ability to learn hierarchical representations makes them particularly powerful for tasks like image recognition, natural language processing, and speech synthesis. To understand deep learning, we need to grasp several key concepts. Let's start with neurons, the building blocks of neural networks. Each artificial neuron receives input, processes it through an activation function, and produces an output. These neurons are organized into layers, typically consisting of an input layer, one or more hidden layers, and an output layer. The connections between neurons have associated weights that are adjusted during training to minimize the difference between the network's predictions and the actual target values. Activation functions play a crucial role in introducing nonlinearity into the network, allowing it to learn complex patterns. Common activation functions include ReLU, rectified linear unit, sigmoid, and tanh. The choice of activation function can significantly impact the network's performance and its ability to handle different types of data. Backpropagation is the algorithm used to train neural networks. It works by calculating the gradient of the loss function with respect to each weight in the network, then updating the weights to minimize the loss. This process is repeated iteratively, allowing the network to gradually improve its performance on the given task. There are several types of neural networks, each designed for specific applications. Convolutional neural networks, CNNs, excel at processing grid-like data, such as images. They use convolutional layers to automatically learn spatial hierarchies of features, making them ideal for tasks like object detection and image classification. Recurrent neural networks, RNNs, are designed to handle sequential data, such as time series or natural language. They have connections that form cycles, allowing information to persist from one step to the next. This makes them particularly useful for tasks like machine translation and speech recognition. Generative adversarial networks, GANs, consist of two neural networks, a generator and a discriminator, that compete against each other. The generator creates synthetic data samples, while the discriminator tries to distinguish between real and fake samples. This adversarial process leads to the generation of increasingly realistic data, with applications in image synthesis, style transfer, and even drug discovery. The real-world applications of deep learning in AI are vast and growing. In healthcare, deep learning models are being used to analyze medical images, predict patient outcomes, and accelerate drug discovery. In finance, they're employed for fraud detection, algorithmic trading, and risk assessment. Autonomous vehicles rely on deep learning for perception and decision making, while virtual assistants use it for natural language understanding and generation. To start your journey into deep learning, we've prepared a structured plan for the next 4 weeks. In week 13, focus on understanding the fundamentals of neural networks, including their architecture and the mathematics behind forward and backward propagation. Week 14 will be dedicated to implementing basic neural networks from scratch using Python, giving you a deep understanding of how they work under the hood. In week 15, we'll explore more advanced architectures like CNNs and RNNs and learn how to use popular deep learning frameworks such as TensorFlow and PyTorch. Finally, week 16 will be all about practical applications. You'll work on real-world projects like image classification, sentiment analysis, or even building a simple chatbot. For free deep learning courses, we highly recommend the Deep Learning Specialization on Coursera by Andrew Enging. This comprehensive series covers everything from neural network basics to advanced architectures and practical tips for building effective models. Another excellent resource is the Practical Deep Learning for Coders course by Fast.ai, which takes a hands-on approach to teaching deep learning. When it comes to frameworks, TensorFlow and PyTorch are the two most popular choices in the industry. TensorFlow, developed by Google, offers a comprehensive ecosystem for building and deploying machine learning models. PyTorch, created by Facebook's AI Research Lab, is known for its dynamic computation graphs and ease of use in research settings. Both frameworks have extensive documentation and community support, so choose the one that aligns best with your learning style and project goals. As you progress through these weeks, you'll find that mastering deep learning opens up a world of possibilities in AI. You'll be able to create models that can recognize objects in images, generate human-like text, or even compose music. The skills you develop will enable you to tackle complex problems that were once thought to be the exclusive domain of human intelligence. As we venture deeper into the realm of AI engineering, it's time to sharpen our focus and explore the power of specialization. While a broad understanding of AI is valuable, true expertise often lies in mastering a specific domain. The question now is, which AI specialization could revolutionize your career? The field of AI is vast, encompassing various subfields that each offer unique challenges and opportunities. Three of the most prominent specializations are natural language processing, NLP, computer vision, and reinforcement learning. Each of these areas has the potential to transform industries and create groundbreaking applications. But how do you choose which path to pursue? Let's start by exploring natural language processing. NLP is concerned with enabling computers to understand, interpret, and generate human language. This field has seen remarkable advancements in recent years, powering technologies like machine translation, sentiment analysis, and chatbots. One of the key concepts in NLP is tokenization, which involves breaking down text into smaller units such as words or subwords. This process is fundamental for many NLP tasks. Another important aspect of NLP is word embeddings, which are dense vector representations of words that capture semantic relationships. These embeddings allow machines to understand the context and meaning of words in a way that's similar to human comprehension. Techniques like Word2Vec and Glove have revolutionized how we represent language in AI systems. Moving on to computer vision, this specialization focuses on enabling machines to interpret and understand visual information from the world. It's the technology behind facial recognition systems, self-driving cars, and medical image analysis. One of the fundamental concepts in computer vision is image preprocessing, which involves techniques like resizing, normalization, and augmentation to prepare images for analysis by AI models. Convolutional neural networks, CNNs, are the backbone of many modern computer vision systems. These specialized neural networks are designed to process grid-like data, making them exceptionally well suited for image analysis. CNNs use layers of convolutional filters to automatically learn and extract relevant features from images, mimicking the way the human visual cortex processes visual information. Reinforcement learning, our third specialization, is a type of machine learning where an agent learns to make decisions by interacting with an environment. This field has gained significant attention due to its applications in robotics, game playing, and autonomous systems. One of the key concepts in reinforcement learning is the Markov decision process, MDP, which provides a mathematical framework for modeling decision-making in situations where outcomes are partly random and partly under the control of a decision maker. A central component of reinforcement learning is the concept of reward functions. These functions define the goal of the agent and shape its behavior. Designing effective reward functions is crucial for training agents that can achieve complex objectives. Techniques like Q-learning and policy gradients are used to help agents learn optimal strategies for maximizing long-term rewards. Choosing a specialization can be challenging, but it's a decision that can significantly impact your career trajectory. When making this choice, consider your personal interests, strengths, and the current market demand. If you're fascinated by language and communication, NLP might be the perfect fit. For those with a strong visual sense or interest in robotics and autonomous systems, computer vision could be an excellent choice. If you're intrigued by decision-making processes and enjoy tackling complex, dynamic problems, reinforcement learning might be your calling. It's also worth considering the current and projected market demand for these specializations. NLP is seeing tremendous growth due to the increasing importance of voice assistants, chatbots, and language translation services. Computer vision is crucial for emerging technologies like autonomous vehicles and augmented reality. Reinforcement learning, while perhaps not as widely applied currently, has immense potential in robotics, game theory, and optimization problems. Fortunately, there are numerous free resources available to help you dive into these specializations. For NLP, the Natural Language Toolkit, NLTK, is an excellent starting point. This Python library provides easy-to-use interfaces to over 50 corpora and lexical resources, along with a suite of text processing libraries. The Stanford NLP Group also offers free online courses and resources that cover a wide range of NLP topics. For computer vision, OpenCV is a powerful open-source library that provides a comprehensive set of tools for image and video analysis. The CS231N course from Stanford University, available online for free, offers an in-depth introduction to deep learning for computer vision. To explore reinforcement learning, David Silver's course on YouTube provides a comprehensive introduction to the field. The OpenAI Gym is another valuable resource, offering a wide range of environments to test and develop reinforcement learning algorithms. Specializing in a specific AI domain can set you apart in the job market. Employers often seek candidates with deep expertise in particular areas, as these specialists can tackle complex problems and drive innovation within their organizations. By focusing your efforts on mastering one of these specializations, you're not just learning a set of techniques. You're positioning yourself as an expert in a rapidly evolving field. You've been immersing yourself in AI concepts, honing your skills, and mastering the tools of the trade. But how do you prove your expertise to potential employers? The answer lies in a powerful tool that speaks louder than any resume: your project portfolio. Creating truly impressive AI projects as a beginner can seem daunting, but with the right approach, you can showcase your skills in a way that both excites hiring managers and fits your current level. A strong AI project portfolio serves multiple purposes. First, it demonstrates your ability to apply theoretical knowledge to real-world problems. This practical experience is invaluable in an industry that values hands-on skills. Second, it showcases your creativity and problem-solving abilities, giving potential employers insight into how you approach challenges. Finally, a well-crafted portfolio sets you apart from other candidates who may have similar educational backgrounds but lack tangible project experience. When building your AI project portfolio, focus on quality over quantity. A few well-executed projects that demonstrate a range of skills are more impressive than a large number of simple or incomplete projects. Each project should have a clear purpose, addressing a specific problem or exploring an interesting concept within AI. A compelling AI project typically includes several key components. Start with a clear problem statement or research question. This shows your ability to identify meaningful challenges in the field. Next, provide a detailed explanation of your methodology, including the algorithms or models you used and why you chose them. This demonstrates your understanding of AI techniques and your ability to select appropriate tools for the task at hand. Data is at the heart of most AI projects, so be sure to discuss your data sources, pre-processing steps, and any feature engineering you performed. This showcases your data handling skills, which are crucial in AI development. Include visualizations of your results and analyses of your model's performance. These elements not only make your project more engaging, but also demonstrate your ability to interpret and communicate complex information. There are several types of projects you can include in your portfolio. Personal projects allow you to explore topics that genuinely interest you, showcasing your passion for AI. These could range from building a chatbot that recommends movies based on user preferences to creating a computer vision system that identifies different species of birds in photographs. Open source contributions are another excellent way to build your portfolio. By contributing to established AI projects, you demonstrate your ability to work with existing code bases and collaborate with other developers. This experience is highly valued in the industry, where teamwork and code maintenance are essential skills. Participating in AI competitions, such as those hosted on Kaggle, can also bolster your portfolio. These competitions often involve real-world datasets and challenging problems, providing an opportunity to test your skills against others in the field. Even if you don't win, documenting your approach and lessons learned can be valuable additions to your portfolio. For beginners looking to create impressive AI projects, consider starting with some of these ideas. 1. Develop a sentiment analysis tool that analyzes social media posts to gauge public opinion on a particular topic. 2. Create an image classification system that can identify different breeds of dogs or cats. 3. Build a recommendation system for a specific domain, such as books, music, or restaurants. 4. Implement a natural language processing model that can generate text in the style of a famous author. 5. Design a reinforcement learning agent that learns to play a simple game like tic-tac-toe or snake. These projects are accessible to beginners, but can be scaled up in complexity as your skills improve. They also cover a range of AI subfields, demonstrating your versatility. When it comes to showcasing your projects, GitHub is an essential platform. Create a well-organized repository for each project, including a detailed RADME file that explains the project's purpose, methodology, and results. Use clear, concise code comments and follow best practices for code organization. This not only makes your work more accessible to potential employers, but also demonstrates your ability to write clean, maintainable code. In addition to GitHub, consider creating a personal website or blog to showcase your projects. This allows you to provide more context and tell the story behind each project. You can discuss your motivation, challenges you faced, and what you learned in the process. A well-crafted project narrative can be just as impressive as the technical details. Remember to update your portfolio regularly as you complete new projects or improve existing ones. This shows potential employers that you're actively engaged in learning and applying new AI concepts. A strong project portfolio can indeed open doors to AI job opportunities. It provides tangible evidence of your skills and problem-solving abilities, giving employers confidence in your capabilities. Many AI professionals have secured interviews and job offers based on the strength of their project portfolios, even without extensive formal experience in the field. You've built an impressive portfolio, but now you're facing a sea of equally qualified candidates. How do you make yourself the clear choice for employers? There's a hidden playbook that top AI professionals use to stand out, and it's not what you might expect. The AI job market is undeniably competitive, with a growing pool of talented professionals vying for coveted positions. However, this challenge presents an opportunity for those who are willing to go the extra mile. By implementing a strategic approach to your job search, you can significantly increase your chances of landing that dream AI role. One of the first steps in preparing for the AI job market is crafting a compelling resume that highlights your unique skills and experiences. Unlike traditional resumes, an AI engineer's CV should focus on showcasing technical proficiency, project accomplishments, and problem-solving abilities. Include specific details about the AI models you've worked with, the data sets you've handled, and the real-world problems you've solved. Quantify your achievements whenever possible, such as improvements in model accuracy or efficiency gains you've achieved. But a strong resume is just the beginning. In the AI field, networking plays a crucial role in opening doors to opportunities that may not be publicly advertised. Engage with the AI community by attending conferences, participating in online forums, and contributing to open source projects. These activities not only expand your knowledge, but also help you build valuable connections with industry professionals. Consider joining AI-focused groups on platforms like LinkedIn or Meetup, where you can engage in discussions, share insights, and learn about job openings. Don't underestimate the power of informational interviews with professionals already working in AI roles. These conversations can provide valuable insights into the industry and potentially lead to job referrals. Staying updated with the latest AI trends and research is non-negotiable in this rapidly evolving field. Employers value candidates who demonstrate a commitment to continuous learning. Follow influential AI researchers and companies on social media, subscribe to reputable AI newsletters, and regularly read academic papers in your area of specialization. This knowledge will not only make you a more attractive candidate, but also prepare you for the technical challenges you'll face in interviews. Speaking of interviews, AI job assessments often involve rigorous technical evaluations. Be prepared to solve complex algorithmic problems, explain machine learning concepts, and discuss your past projects in detail. Practice coding challenges on platforms like LeetCode or HackerRank, focusing on problems related to data structures, algorithms, and machine learning implementations. During interviews, showcase your ability to think critically about AI problems. Employers are often more interested in your problem-solving approach than in whether you arrive at the perfect solution. Be prepared to discuss the ethical implications of AI and demonstrate an understanding of how AI solutions impact businesses and society at large. When it comes to finding AI job opportunities, cast a wide net. While popular job boards like Indeed and LinkedIn are good starting points, also explore AI-specific job platforms such as aijobs.net or mljobs.com. Don't overlook the career pages of AI-focused companies and research labs. Many cutting-edge AI roles are filled through direct applications on company websites. Consider reaching out to AI recruiting agencies that specialize in placing candidates in tech roles. These agencies often have insider knowledge of the job market and can provide valuable guidance on positioning yourself as a strong candidate. One strategy that can set you apart is developing a niche expertise within AI. While having broad knowledge is important, specializing in a specific area such as natural language processing, computer vision, or reinforcement learning can make you a sought-after candidate for certain roles. Highlight this expertise in your resume, portfolio, and during interviews. Remember that soft skills are equally important in the AI field. Effective communication, teamwork, and the ability to explain complex concepts to non-technical stakeholders are highly valued. During interviews, provide examples of how you've collaborated with cross-functional teams or presented technical findings to diverse audiences. Lastly, don't underestimate the power of a well-crafted cover letter. Use this opportunity to tell your unique story, explaining your passion for AI and how your background and skills align with the company's goals. A personalized, thoughtful cover letter can be the differentiator that gets your resume moved to the top of the pile. Congratulations on reaching the final stretch of your AI engineering journey. You've built a solid foundation, mastered essential skills, and even created an impressive portfolio. But in the world of artificial intelligence, the learning never truly stops. As you stand at the threshold of your new career, it's crucial to understand that staying relevant in AI requires more than just landing that first job. It demands a commitment to continuous learning and adaptation. The field of AI is evolving at a breakneck pace. What's cutting edge today might be outdated tomorrow. This rapid evolution presents both a challenge and an opportunity for AI professionals. On one hand, it can be daunting to keep up with the constant stream of new research, techniques, and tools. On the other hand, this dynamic environment offers endless possibilities for growth and innovation. So, how can you stay ahead in this rapidly changing landscape? The key lies in adopting a mindset of lifelong learning. This means not only staying updated with the latest developments, but also actively seeking out new knowledge and skills. It's about cultivating a sense of curiosity and a willingness to explore beyond your comfort zone. One of the most effective ways to keep your skills sharp is by diving into advanced AI topics. Let's explore a few areas that are currently shaping the future of AI. Transfer learning is a technique that allows AI models to apply knowledge gained from one task to a different but related task. This approach significantly reduces the amount of data and computational power needed to train new models. For example, a model trained on general image recognition could be fine-tuned for a specific task like identifying plant diseases, saving time and resources. Federated learning is an innovative approach that enables machine learning models to be trained across multiple decentralized devices or servers holding local data samples without exchanging them. This technique addresses privacy concerns by allowing models to learn from diverse data sets without compromising data security. It's particularly useful in scenarios where data privacy is paramount, such as healthcare or finance. Explainable AI, XAI, focuses on making AI systems more transparent and interpretable. As AI increasingly influences critical decisions in areas like healthcare, finance, and criminal justice, it's crucial to understand how these systems arrive at their conclusions. XAI techniques aim to provide clear explanations for AI decisions, making them more trustworthy and accountable. As you delve into these advanced topics, it's equally important to consider the ethical implications of AI. The rapid advancement of AI technology has raised significant ethical concerns, from data privacy and algorithmic bias to the potential impact on employment and social structures. Understanding AI ethics and responsible development practices is not just a moral imperative, it's becoming a critical skill for AI professionals. Responsible AI development involves considering the potential consequences of AI systems and taking steps to mitigate negative impacts. This includes ensuring fairness and avoiding bias in AI models, protecting user privacy, and designing AI systems that are transparent and accountable. As an AI engineer, you'll need to be well versed in these principles and able to apply them in your work. Staying updated with the latest AI developments can seem overwhelming, but there are several strategies you can employ. One of the most effective ways is to regularly read research papers from top AI conferences and journals. Websites like archive.org provide access to preprints of the latest AI research. While the technical content can be challenging, even skimming abstracts and conclusions can help you stay informed about emerging trends and breakthroughs. Attending AI conferences, either in person or virtually, is another excellent way to stay current. These events offer opportunities to learn about cutting-edge research, network with other professionals, and gain insights into industry trends. Major conferences like NeurAPA's, ICML, and CVPR are gold mines of information, but don't overlook smaller, more specialized events in your areas of interest. Online communities and forums can be invaluable resources for continuous learning. Platforms like Reddit's R machine learning, Stack Overflow, and AI-focused Discord servers provide spaces to discuss ideas, ask questions, and share knowledge with peers from around the world. Engaging in these communities can help you stay updated and even contribute to solving real-world AI problems. For more structured learning, there are numerous resources available. Online platforms like Coursera, edX, and Udacity offer advanced AI courses taught by experts in the field. Many of these courses are free to audit, allowing you to access high-quality educational content without financial barriers. Additionally, websites like Fast AI provide cutting-edge courses on deep learning and its applications. Contributing to the AI community is not only a way to give back, but also an excellent method for deepening your own understanding. Consider contributing to open-source AI projects on platforms like GitHub. This can involve anything from fixing bugs to implementing new features or improving documentation. Such contributions enhance your skills, build your professional network, and raise your profile in the AI community. Writing blog posts or creating tutorial videos about AI concepts you've mastered is another great way to contribute while reinforcing your own learning. Explaining complex ideas in simple terms can deepen your understanding and help others in their AI journey. Platforms like Medium, personal blogs, or YouTube are great for sharing your knowledge and insights. As we venture into the realm of ethical considerations in AI development, a critical question emerges. How can we ensure that the powerful AI systems we create today will shape a better world for tomorrow? This isn't just a philosophical musing, it's a pressing concern that every AI engineer must grapple with as they push the boundaries of technology. The rapid advancement of AI has brought unprecedented capabilities, but it has also raised significant ethical challenges. As AI systems become more integrated into our daily lives, their potential impact on society grows exponentially. From automated decision-making in healthcare and finance to the use of facial recognition in law enforcement, AI technologies are reshaping fundamental aspects of human interaction and governance. One of the primary ethical considerations in AI development is the issue of bias. AI systems are only as unbiased as the data they're trained on and the humans who design them. Unintentional biases can creep into AI models, leading to discriminatory outcomes. For instance, an AI-powered hiring tool might inadvertently favor certain demographic groups over others, perpetuating existing societal inequalities. AI engineers must be vigilant in identifying and mitigating these biases, which often requires diverse teams and rigorous testing protocols. Privacy is another crucial ethical concern. AI systems often rely on vast amounts of personal data to function effectively. However, the collection, storage, and use of this data raise significant privacy concerns. AI engineers must grapple with questions such as, how can we build AI systems that respect individual privacy rights? What safeguards should be in place to prevent misuse of personal data? The challenge lies in striking a balance between leveraging data for AI advancement and protecting individuals' right to privacy. Transparency and accountability are equally important ethical considerations. As AI systems become more complex, understanding how they arrive at decisions becomes increasingly difficult. This black box problem can lead to a lack of trust and accountability. For example, if an AI system denies a loan application, the applicant should have the right to understand why. AI engineers need to work on developing explainable AI models and implementing mechanisms for auditing AI decisions. Real-world applications of AI have already highlighted these ethical challenges. In the criminal justice system, AI-powered risk assessment tools have been criticized for potentially reinforcing racial biases. In healthcare, AI diagnostic systems raise questions about patient privacy and the role of human judgment in medical decisions. Social media algorithms designed to maximize engagement have been scrutinized for their potential to spread misinformation and polarize societies. As the architects of these powerful systems, AI engineers play a crucial role in promoting responsible AI development. This responsibility extends beyond technical expertise to include ethical awareness and proactive consideration of the societal impacts of their work. AI engineers should advocate for ethical guidelines within their organizations and push for the integration of ethical considerations throughout the AI development lifecycle. Fortunately, there are growing resources available for learning about AI ethics. Organizations like the IEE Global Initiative on Ethics of Autonomous and Intelligent Systems provide comprehensive ethical guidelines for AI development. Universities are increasingly offering courses on AI ethics, and online platforms like Coursera and edX feature specialized programs on this topic. AI engineers should make a conscious effort to engage with these resources and stay informed about evolving ethical standards in the field. Incorporating ethical considerations into AI projects requires a multifaceted approach. One strategy is to implement ethics review boards within organizations, similar to institutional review boards in academic research. These boards can evaluate AI projects for potential ethical issues before they're implemented. Another approach is to adopt ethics by design principles, where ethical considerations are integrated into every stage of the AI development process, from data collection to deployment. Diversity in AI teams is also crucial for ethical AI development. Teams with diverse backgrounds and perspectives are more likely to identify potential ethical issues and develop solutions that work for a broader range of users. AI engineers should advocate for inclusive hiring practices and create environments where diverse voices are heard and valued. By prioritizing ethical considerations in AI development, engineers can enhance the value and impact of their solutions. Ethical AI systems are more likely to gain public trust, comply with regulations, and stand the test of time. Moreover, addressing ethical concerns often leads to more robust and versatile AI solutions that can be applied responsibly across various domains. In the rapidly evolving world of AI, the hunger for knowledge and skills has created a fertile ground for both legitimate educational opportunities and, unfortunately, deceptive schemes. As aspiring AI engineers seek to equip themselves with the tools and expertise needed to succeed in this competitive field, they must navigate a landscape fraught with potential pitfalls. The allure of quick success and instant expertise can be tempting, but it's crucial to approach online AI education with a discerning eye. The financial and career risks associated with falling for AI learning scams are significant. Not only can these fraudulent offerings drain your wallet, but they can also waste valuable time and potentially lead you down a path of misinformation. Imagine investing months or even years into a program that promises to make you a sought-after AI expert, only to discover that the skills you've acquired are outdated, inaccurate, or simply not recognized by potential employers. The consequences can be devastating, setting back your career aspirations and eroding your confidence in the process. To protect yourself from these risks, it's essential to be aware of common red flags in AI course offerings. One of the most prevalent warning signs is the promise of unrealistic outcomes. Be wary of courses that guarantee job placements or claim to make you an AI expert in an impossibly short time frame. Legitimate AI education takes time and effort. There are no shortcuts to mastering complex concepts and practical skills. Another red flag is a lack of transparency about the course content or instructor qualifications. Reputable programs will provide detailed syllabi and clear information about who will be teaching the material. If a course is vague about what you'll learn or who you'll learn it from, it's wise to be skeptical. Excessive pressure to enroll or limited time offers that create a false sense of urgency are also indicators of potential scams. Legitimate educational institutions and platforms don't typically use high-pressure sales tactics to recruit students. When evaluating AI courses, it's crucial to vet both the instructors and the content thoroughly. Look for instructors with verifiable credentials and real-world experience in AI. Check their professional profiles on platforms like LinkedIn or research their publications and contributions to the field. The content itself should be up-to-date, comprehensive, and aligned with current industry standards and practices. Fortunately, there are numerous reputable sources for AI education and certification. Universities offering online courses through platforms like Coursera, edX, or Udacity are generally reliable options. These platforms often partner with well-known institutions and industry leaders to provide high-quality content. Professional organizations such as the IEEE Computer Society and the Association for Computing Machinery, ACM, also offer valuable resources and certifications. Tech giants like Google, Microsoft, and Amazon have developed their own AI and machine learning certifications, which are widely recognized in the industry. While these may come with a cost, they often provide a solid return on investment in terms of skill development and career advancement. When evaluating the credibility of online AI resources, consider the following tips. 1. Check for accreditation or partnerships with recognized institutions. 2. Look for courses that provide hands-on projects and real-world applications. 3. Read reviews and testimonials from past students, but be wary of overly glowing reviews that seem inauthentic. 4. Investigate the course provider's track record and reputation in the AI community. 5. Ensure the curriculum covers fundamental concepts as well as cutting-edge technologies. 6. Look for programs that offer ongoing support and resources beyond the course duration. Building a cost-effective AI learning plan requires strategic thinking and resource allocation. Start by leveraging free resources such as open-source courses, tutorials, and documentation provided by reputable organizations. Platforms like Kaggle offer free datasets and competitions that can help you apply your skills in practical scenarios. Consider joining online communities and forums dedicated to AI and machine learning. These can be invaluable sources of peer support, mentorship, and up-to-date information on industry trends. Participating in open source projects can also provide hands-on experience and networking opportunities without financial investment. When you're ready to invest in paid courses or certifications, prioritize those that align closely with your career goals and offer tangible skills that are in demand in the job market. Look for programs that provide certificates of completion or badges that can be showcased on your professional profiles. Remember that building a strong foundation in mathematics, statistics, and programming is often more valuable than chasing the latest AI buzzwords. Many of these fundamental skills can be acquired through free or low-cost resources before moving on to more specialized AI topics. As we peer into the future of AI engineering, the landscape is brimming with potential for groundbreaking advancements and transformative applications. The field is evolving at an unprecedented pace, with new technologies and methodologies emerging almost daily. This rapid progression opens up a world of possibilities for aspiring AI engineers, but it also presents challenges in staying current and adapting to shifting job market demands. One of the most exciting frontiers in AI development is the pursuit of artificial general intelligence, AGI. Unlike narrow AI systems designed for specific tasks, AGI aims to create machines with human-like cognitive abilities across a wide range of domains. This ambitious goal involves developing AI systems that can reason, learn, and adapt to new situations much like humans do. While AGI remains a distant target, progress in this area could revolutionize industries from healthcare to finance, creating new roles for AI engineers focused on developing and implementing these advanced systems. Quantum AI represents another cutting-edge area of development that holds immense promise. By harnessing the principles of quantum mechanics, quantum AI has the potential to solve complex problems that are currently intractable for classical computers. This field combines expertise in quantum physics, computer science, and AI, creating opportunities for interdisciplinary specialists. As quantum computing hardware continues to advance, we can expect to see a growing demand for AI engineers with knowledge of quantum algorithms and their applications in areas such as cryptography, drug discovery, and financial modeling. Neuromorphic computing is yet another emerging trend that aims to bridge the gap between artificial and biological intelligence. By designing hardware and software systems that mimic the structure and function of the human brain, neuromorphic computing offers the potential for more energy efficient and adaptive AI systems. This field could lead to the development of AI that can learn and process information in ways that are more similar to human cognition, opening up new possibilities in areas such as robotics, natural language processing, and sensory processing. As these technologies advance, we're likely to see the emergence of new roles and specializations within AI engineering. For instance, AGI researchers will be needed to tackle the complex challenges of creating truly general-purpose AI systems. Quantum AI engineers will be in high demand to develop and optimize algorithms for quantum computers. Neuromorphic computing specialists will be sought after to design and implement brain-inspired AI architectures. The impact of these AI advancements will be felt across numerous industries. Healthcare is poised for significant transformation, with AI potentially revolutionizing drug discovery, personalized medicine, and medical imaging analysis. In transportation, the continued development of autonomous vehicles will create opportunities for AI engineers specializing in computer vision, sensor fusion, and decision-making algorithms. The financial sector is likely to see increased adoption of AI for risk assessment, fraud detection, and algorithmic trading, requiring AI engineers with domain-specific knowledge. To position oneself for these future opportunities, aspiring AI engineers should focus on developing a strong foundation in core AI concepts while also staying adaptable to emerging technologies. A deep understanding of machine learning algorithms, neural network architectures, and data science principles will remain crucial. However, it will be equally important to cultivate skills in areas such as quantum computing, neuromorphic engineering, and ethical AI development. Continuous learning will be paramount in this rapidly evolving field. Engaging with the latest research papers, attending conferences, and participating in online courses or workshops can help AI engineers stay at the forefront of technological advancements. Developing expertise in specific domain areas, such as healthcare AI or financial AI, can also provide a competitive edge in the job market. As AI systems become more complex and influential, the ability to address ethical considerations and ensure responsible AI development will be increasingly valued. AI engineers who can navigate the ethical implications of their work and implement safeguards against bias, privacy violations, and other potential harms will be in high demand. The future of AI engineering is not just about technical skills, it's also about vision and creativity. As AI capabilities expand, there will be opportunities to apply these technologies to solve previously intractable problems or create entirely new products and services. AI engineers who can think outside the box and envision novel applications of AI will be well positioned to drive innovation and make significant impacts in their chosen fields. As we conclude this roadmap for aspiring AI engineers, it's clear that the journey ahead is both challenging and immensely rewarding. The field of AI demands dedication, a commitment to continuous learning, and a strong ethical compass. But for those willing to put in the effort, the potential to shape the future is boundless. This comprehensive plan provides a solid foundation, but it's just the beginning. The real adventure starts when you take that first step. Whether you're drawn to machine learning, natural language processing, or computer vision, there's a world of possibilities waiting to be explored. Remember, as an AI engineer, you have the power to create technologies that can positively impact millions of lives. So why wait? Start your AI learning journey today and become part of the generation that's building tomorrow's innovations.